right, we're still continuing. 3-5, we're solving for how many variables? 3. We're dealing with 3 variables right here. System of equations with 3 variables. All right, so Haley, could you set up your part of the problem right here? And you can use any variables that you want. Go ahead, Haley. We have 6R, 2P, and 1A, and you spent a total of $6. So there's the blue equation right there. All right? All right, knowing how Haley set this up, Shelby, why don't you do the red equation? 3R plus 4P 5A equals 12. I would have to say I'd probably be more, if it was me buying stuff, I'd probably totally spend a lot of money on air hockey, all right, and not as much on racing games. Okay, I like the old air hockey. All right. And last but not least, JC, who has forgiven me for misspelling your name, I apologize once again. All right. Okay, I corrected it then. Okay. What's the last one? What's it gonna look like? 2R
plus 7P
7P
plus 4G
plus what for it? For air hockey.
equals 1225.
1225. So you spent the most money out of all. All right. Because you just have the most luggage. So what we're going to do right now, does anybody remember, by the way, I'm going to give us a little hint. This is our first equation. This is our second. And this is our third. Does anyone remember the process that we did yesterday of how do we set things up? So there's a specific process we talked about that could work every single time. All right, Garrett, tell me what to do.
First equation over the second.
First equation.
Then the first one over the third.
Okay. First over second, first over third. Here we go. First equation over the second equation. So there's my first over the second. And then once again, I'm going to take my first equation and I'm going to place it over my third equation. All right. Now, we just chose the first over the second and the first over the third. Now, if you wanted to do the second over the first and the second over the third, you could do it. If you want to do the third over the first and the third over the second, you could do it. There's lots of ways. My suggestion, just to make it easier for you, is just to take the first over the second and the first over the third, and then what do you scan for? You scan this equation, and you scan this equation, and you look for the easiest letter to eliminate. Now, my suggestion for you today is to think like a pirate. Arr. Okay? Now, by the way, we thought like a pirate, and we wanted to eliminate all of our R's. What would I have to multiply the bottom equation by to get rid of a positive 6R? Negative 2. I like it. So we're going to multiply the bottom equation by a negative 2. Now, Garrett, over here, what did I messed up here. Look at that. I put 6P. I apologize. It's supposed to be a 6R. My apologies. There we go. It's okay to make a mistake as long as you catch it. All right. What do I have to multiply this number, this 2R, by to eliminate a 6R? Negative 3 is correct. Because negative 3 times 2R is a negative 6R, and then those will cancel out. So right now, what I want everybody to do right now is to distribute negative 2 throughout the entire equation here, and distribute negative 3 throughout the entire equation here. Wait, I'll do it right now. Ready? Right here, right here, right here, and all the way over there.
Why did you choose?
I will explain after we do it, and hopefully you will see why we did it. Negative 6R minus 21P minus 12P equals 30. once you finish distributing, then I want you to take the blue equation and carefully place it directly underneath both of your new equations so that we can add them together. And hopefully when you do this, Justice, you will see why we chose what we chose. The reason we multiplied everything in this bottom equation by a -2 is so that I could get a -6r, because I knew a -6r and a +6r would cancel out. And the reason we multiplied everything by a -3 here to get a -6r is so that this -6r would cancel out this +6r. And what does that mean? It means we're going from a 3-variable equation down to a 2-variable equation. All right, now let's add these two equations together. We see that these clearly zero out. -8p and 2p gets us a -6p. -10a and an a is a -9a. -24 and a 6 is a -18. Wow, that's a lot of negatives. You know what you can do if you want to, anytime you want. If you see a whole bunch of negatives, you're like, I don't like all those negatives. You can just take that whole thing that you just did, multiply it by a negative, you just get 6p plus 9a equals 18. That I would say this looks a lot nicer and neater, a lot easier to work with. So anytime you see a whole bunch of negatives in an equation, just multiply everything by a negative. That gets rid of it. Okay? All right, so go over here. I'm going to change colors here. Make everything, we'll do green. What's -21p plus 2p? That's a -19p. -12a and an 8. -11. Ooh, -36.75 and a +6. There we go. Now, I'm going to leave everything negative here, because if these are all positive and these are all negatives, eventually something can cancel each other out. So let's go down here and write these two equations, one right on top of the other. Oh, thank goodness. We're down to 2 variables instead of 3 variables. Now all I have is the p values, which represent the pinball, and the a values, which represent the price for the air hockey. Okay, let's scan this real quick. Which letters do you think would be easiest to eliminate? The a's or the p's? P's? All right. We have a disagreement. Okay, by show of hands, I'm gonna pause this. We're gonna do by show of hands. Well, I'm sorry, the class vetoed you. All right, we're gonna eliminate the a's. Now, we already have a negative and we have a positive, so that's good. So when we add things together, they'll cancel out. Here's what we're gonna do. We're gonna take the top equation and the bottom equation. We're gonna multiply the top by what number do you think? What's the least common multiple between a 9 and an 11? 99. So we got to multiply the top by an 11. We got to multiply the bottom by a 9. So watch what happens. I want you to distribute an 11 throughout the equation in the top and a 9 throughout the equation in the bottom. And we'll see what we get. We've got 11 times 6p, which is a 66p. We've got 11 times a 9a, which is a 99a. And we've got an 11 times an 18, which is? What is it? 198. All right, now we have 9 times -19p. What's that? -171 minus 99a equals, what's 9 times -30.75? 276.75. Perfect. Now, the whole reason, here's what I'm hoping you guys realize. The whole reason we multiplied the top by an 11 and the bottom by a 9 is so that these guys right here, what would happen if we add them together? They would disappear and eliminate. So go ahead, what were you saying? Okay, what's negative 171p plus a 66p? Negative 105p equals, what's negative 276.75 added to a 198?
Negative 78.75.
Negative 78.75. The last step is to divide both sides by negative 105. And the price for pinball is 75 cents is correct. 75 cents. So we did all that work so we could find the price of pinball. It would be 75 cents. Now, we did the hardest part. This is the hardest part. Everything else is super easy because we just plug it in. So by the way, Justice, you see this equation right here? The 6p plus 9a? Right there?
Yeah.
Let's use it. It makes it very, 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 very easy. Here we go. 6p plus 9a equals 18. But this time, what am I going to plug into that right there? We're going to plug in a 0.75 right there. What's 6 times 0.75? I think that's 450, right? 4.5 plus 9a equals 18. Now we have an Algebra 1 problem. Just got to do what? Take away 450 from each side. All right, we get 9a equals 1350. And when we divide both sides by 9, we get the price of air hockey. And what is the price of air hockey? 13.5 divided by 9. What'd you get? $1.50. Wow. If you get a good game of air hockey for $1.50, it's going to be a nice air hockey table. All right, so for $1.50, I have a price of air hockey. I have the price of the pinball. What's the only thing we need to find now? The racing game. So now, once you have these two, what you have to do is you need to go up to the top. Let's go up to the top and take a look at one of our original equations. You guys see this one right here, the very, very, very first one? Here we go. 6r plus 2 times p. Now what number am I going to plug in for p? What do we find for the pinball? 0.75 plus, whoop, too far, plus our a value. And what was the price of air hockey? 150. All right, so put 1.5, and that equals a total of $6. So right now we're going to solve right here. We're solving for r. That's what I'm going to write. Solve for r. So we have 6r plus $1.50 plus another $1.50 equals 6. 2 times 0.75 is $1.50. What do $1.50 and $1.50 add up to? That's $3. Subtract 3 from both sides. 6r equals 3. R equals a half, but more importantly, 50 cents. All right? So the price of pinball was 75 cents. The price for the air hockey we found was $1.50. And the price for the racing game was 50 cents. And right here, everybody, that would be par for the course.
Okay.